Okay, so the first section of the course is section 1.1, and it's about systems of linear equations and matrices. So I want to start by reminding you of a key fact that we're going to need going forward, and that is the following. So we will recall, if I have the equation of a line in R2, let's write this down. So the equation of a line in R2, by the way, remember R2 is just the xy plane. If I draw the x-axis and the y-axis, here I got the origin, right where the two axes intersect. This is R2, or R squared if you want. Two-dimensional real space, and there's a lot of names for it, but it's often called the Cartesian plane. That's what I mean by R2. So the equation of a line in R2, that's what we're actually talking about, may be written as follows. And the form that you can write it in is a times x plus b times y is equal to c. And there's a few things I want to say about this before we end this sentence. Notice that there's 5 letters here. A, X, B, Y, and C. There's actually 5 letters. All of those represent some unknown number at this stage, but there's a difference between the X and the Y and the A, the B, and the C. So I want to make that distinction at this point. So X and Y are the variables. So they're unknown quantities which can change. It could be many different values. It could be one value and then there could be a different value. You should be considering many possible values for the variables, whereas the other letters, A, B, and C, these are constants. So they're unknown as well, but whatever number those letters represent, they're fixed, they're constant, they're not going to change. So that's a key difference between the constants and variables. So we'll just make that distinction at this point. And then another thing I want to say, this extra requirement here, is that A and B can't both be 0. And why is that? A lot of times you'll just tacitly make that assumption without even realizing you're making that assumption. But let's pause for a moment here and really look at why that's important, and then we'll go forward with that assumption from here. So if A were 0, this first term would just disappear because it doesn't matter what x is. If you multiply it by 0, it evaluates to 0. And now if b were 0, then the second term is also equal to 0. So if a and b were both 0, the left-hand side of this equation would be 0. So then, well, the truth of this equation would depend entirely on the value of c. If c happened to also be 0, well, then the equation would always be true. And if c happened to be anything else non-zero, well, if your left-hand side is 0 and c is non-zero, well, then that means the equation would always be false. And what that would mean is that the truth of this equation has absolutely nothing to do with the values of x and y. And that's not an interesting case. What you want is you want to talk about situations where for some values of x and y, this equation is true, and for other values of x and y, this equation is false. That's the situation that we're trying to describe or lay out as clearly as we can. And really, to make sure that that's the case, we need to make sure that both a and b are not 0. So that's, a lot of times this will just be true automatically, but it's worth mentioning at this point. Just a couple of notes, some terminology. Let's write a couple more things down about this. So a and b are referred to as coefficients. They have names. And the word coefficient is typically used in mathematics to describe a constant or a scalar that's being multiplied onto some other quantity. So in this case, the reason this word coefficient is used is because A is being multiplied onto the variable x, and b is being multiplied onto the variable y. So if you wanted to be more specific, you could say that a is the coefficient of x, and b is the coefficient of y. So, but more generally, we'll just say that they're coefficients. And then c also has a name. C is called the constant term. Why is it called the constant term? Well, it's a constant, for one. It was listed under these three constants, but also it's all by itself over here. It's not multiplied onto anything, so it makes up a term all on its own. Right? So that's how we call it the constant term. So that's just a nice way to remember that. But these names really just give us a way to conveniently refer to these objects with meaningful names.